A hose sensor is a device that can collect data on vehicles using a pressure sensor that detects when a vehicle drives over its attached hose. It's commonly used by cities to collect data on traffic to help make informed decisions on how to design roads and make the city's infrastructure as safe and effective as possible. The sensor was designed and constructed to collect data on the streets surrounding our school and to get a deeper understanding of their safety and design. The ultimate goal was to deploy the sensor, collect traffic data, and put together a report to the City of Vancouver on the safety and effectiveness of the infrastructure in the neighborhood.
The hose sensor uses an Arduino Uno to collect and store traffic data. This Arduino uses the BMP280 pressure sensor to detect the change in air pressure from a vehicle. The BMP280 is a sensor that works by detecting the pressure exerted in from the air and outputting it as the voltage to the analog parts of the Arduino. The Arduino then uses various libraries with its code to convert these voltages into calibrated data points, then stores them into a micro SD card. This is all powered off of a single 9-volt battery connected to the Arduino, which powers the rest of the system.
The basic function of the code is that the BMP280 periodically reads the air pressure and sends the data to a file on the SD card. When a car, bike, or anything rolls over the hose, pressure inside the hose rises and spikes, and the spike in pressure readings is recorded on our SD card.
In order to safely collect data on vehicles, a home was needed for the electronic parts of this build. This home had to be hard to vandalize, waterproof, and able to be stored outside for extended periods of time. Because of these factors, an ammunition box was chosen. The ammunition box has a hole that was drilled into it for the rubber hose to be inserted in. The hose is then fitted to an airtight chamber that connects the hose to the pressure sensor. On the other end, the hose will be sealed in order to prevent air pressure from leaking out and causing any faulty results.
The ultimate goal of this project was to deploy a sensor that collects traffic data and to send a report to the City of Vancouver on the infrastructure around the school. Due to certain laws, it was impossible to deploy the sensor on the street and collect actual traffic data. However, we were still able to test and deploy a sensor that collects data within school grounds. The next steps for this project would involve creating a two-hose system to collect data on speed and direction, in addition to the number of cars. Another stretch goal for this project could be getting permission from the city to deploy the sensor on the roads and collect actual traffic data to present to the City of Vancouver.